But yeah, so we are on page 99 in our handy dandy notebook. And so solving quadratics equations using zero property. This is 5.6a. All right. So zero product property. Zero product property is saying that if you have two factors, A and B, equal to 0, that means that one of the factors has to be equal to 0, right? Does that make sense? Otherwise, could I get a product of 0? No. So one of them has to be equal to 0. Okay. Now, how does that tie into our quadratics? Well, when you have binomial factors, so this is a binomial. These are binomial factors. Reason why they're binomial factors is because you're adding and subtracting and they're factors being multiplied, something being multiplied. So we have binomial factors x minus a and x minus b. One of them or both of them can be equal to 0 in order for this to be a true statement. So in order to solve these, you set them equal to 0. So you set each factor equal to 0 and then just solve. Okay, so the steps that we're going to follow should be in your next box. So the steps to solve. Okay, you're going to rewrite in standard form, which means that you're going to be in ax squared plus bx plus c, and it must be equal to 0. So we're going to set it equal to 0. Okay, then we're going to factor the quadratic expression. So you're going to factor. Factoring means you're going to check and see if there's a GCF. Is it a simple trinomial? Is it going to require X box or grouping or et cetera, et cetera? Okay, what skills we've used thus far. Okay, then you're going to use a zero product property, which just means that you're going to take each factor and set it equal to 0. So you take your factors and set them equal to 0. Then you're going to solve for X. So using inverse operations. What does inverse operations mean? Anyone? Inverse operations. You do the opposite. So if you're adding, then you're going to need to subtract. Yeah, that's it. If you're multiplying, then you need to divide. So inverse operations essentially is us doing PEMDAS backwards. You're undoing the whole thing. So remember we talked about SADMEP, PEMDAS backwards. Okay. Then you're going to check yourself. So plug your answers into the original problem and check yourself. When you ask me, did you get something right? I'm going to ask, did you plug your values back in? I'm not going to tell you if you're right or wrong. I'm going to tell you, did you plug your values back in? Because you can check yourself. All right. So those are our steps that we're going to follow. Any questions about any of this step so far? No. All right, let's dive in. So first example we have x squared minus 24x plus 144 equals 0. So step 1 is to make sure that it's in standard form. Is this in standard form? Yes, it is in standard form and set equal to 0. So we're good to go. Step 2 is to factor. You have to decide what kind of factoring that we have. Since our a coefficient equals 1, that means that we have a simple factor. And simple factor means all I'm asking myself is what multiplies to give me 144, but adds to give me negative 24, right? So the factors of 144, we have 1 and 144. We have 2 and, I just had a brain fart, 72. We have 3 and, when is that? 48, 3 and 48. Felt right, seems right. But you get it, right? Dot, 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 dot. What's the most obvious one? Good job. All right, most obvious is 12, negative 12 and negative 12. Why does it have to be negative? Because our 24 is negative, right? Okay, so therefore our factor is x minus 12 times x minus 12 equals 0. Can I simplify this factor? Can I can write it as x minus 12 squared, right? Yes?
Yes.
So that's factoring. Questions about the factor? All right, then step 3 is you take your factor and you set it equal to 0, which is what I already did. Done. And now you're going to solve. Step 4 is to solve. So what do I need to do to get x by itself? Well, the first thing I got to do, I take the square root to get rid of the square. Taking the square root of 0 is going to be what? 0. And then I need to do what? Inverse operation, guys. Inverse of subtracting. I'm going to add 12. And we get x equals 12. And I'm like, man, I'm really not sure if I did that right. Let me see. So if I plug 12 back in, I get 12 squared minus 24 times 12 plus 144. This equals 144 minus 288 plus 144, and that equals 0. All right, what are your questions?
Pretty straightforward.
Pretty straightforward. Good, I'm glad you say that and that there's no questions, because I would like for you to try example 2 at your table.
All right, let's do the final one. Is this a standard form? No, that's
Let's think about it. So step 1 was, are we in standard form?
Yes, we are.
Yes, we are. Step 2 is to decide what type of factoring do you have here?
Simple.
We have simple because a equals 1. So all I have to do is ask myself, what multiplies to give me positive 16, but adds to give me negative 10?
-8, -2.
Perfect. -8 and -2. So your factors are x minus 8 and x minus 2.
Okay, I got it.
Yes. Step 3 is you take each factor and set it equal to 0. So you have x minus 8 equals 0, and you have x minus 2 equals 0. Take each factor and set equal to 0. And then step 4 is you solve for x using inverse operations. What is the inverse of subtracting 8? What is the inverse of subtracting 2? So your two solutions are okay. So step 5 is if you're like, ooh, I'm not sure if I did this right. What do? You plug in and check. When you're plugging in check, you're checking them individually. So if I'm plugging in for 8, I have 8 squared minus 10 times 8 plus 16. That gives me 64 minus 80 plus 16. That gives me negative 16 plus 16. Does that equal 0?
Yes.
Yes. So that means I did it correct. If I'm going to check the 2, so 2 squared minus 10 times 2 plus 16. That gives me 4 minus 20 plus 16. That gives me negative 16 plus 16. Did that come out right? Yes. So what does that tell me about my answers? I am super right. All we did to check was plug in and multiply and subtract and add. All right, what are your questions, comments, concerns, hesitations, confusions?
Now you pretty much cleared it up. Did the Quadratic
Yeah.
Did the Quadratic guys.
Okay. All right. Example 3 is an example of not being in standard form. Okay. And it's a simple fix to put it into standard form. Anyone wants to take a stab at what the simple fix is? Yes, Gerardo.
Bye, right there.
Move the 2 outside by putting it
No, Gerardo, you're doing too much, but I love your effort. Subtract 15. We just got to move the 15. Okay, that's it. You just got to subtract the 15. So once you subtract 15, you now have 2x squared plus x minus 15, guys, equals 0. Now am I in standard form? Yes. You didn't see the 15. I didn't even see that. Okay, so standard form again means that you have your ax squared plus your bx plus or minus your c equals 0. Am I there? Yes. All right. That's step 1. Step 2 is to now factor. Well, we have to determine what kind of factoring. Well, this time our a is greater than 1. So is this a simple factoring? No, this is not simple. This is a complex factor, which means that you either are going to use Xbox or you're going to use grouping, whichever one your heart tells you to do. I'm going to model it with Xbox, if that's okay. Okay, so remember for Xbox, you have an X, and the parts of the X are made up of your terms. So you have your A times your C. I have 2x squared times negative 15. What is 2x squared times negative 15? Negative 30. My B term, what is my B term if nothing's there? Casper the Friendly 1. So I'm asking myself, what multiplies to give me negative 30, but adds to give me 1? So what two numbers multiply to give me negative 30, but add to give me 1? A 6 and a negative 5. Because 6 times negative 5 is negative 30. 6 plus negative 5 is 1. Do we understand? You see where those numbers came from?
Yeah.
All right, then we go to the box. Hence why it's called Xbox. All right, I don't know. Me? I don't know. No, I didn't. All right, so first box is always your first term. What is our first term? 2x squared. Last box is always your last term. What is our last term? Negative 15. 0 is what we're equal to. Okay. Your middle of your box are the numbers that made your x work. And it doesn't matter where you put them. So that would be 6x and negative 5x. Once you're in X box, all you're doing is finding the greatest common factor of every row and every column. So the first row, what is their GCF? 1 what? 1x. Second row, what is their GCF? What is 3? First column, what is its GCF? Perfect. Second column, what is its GCF? Perfect. So therefore, our factors are the outside, x plus 3 and 2x minus 5. If you're wondering where we learned this, this is your 5.5B notes. So if you do not have them, have not taken them, or you need a refresher, I strongly encourage you to watch 5.5B notes all over again. Okay. What are your questions about Xbox? All right, step 3 is you're going to take each factor and set it equal to 0. So that means we have x plus 3 equals 0. And we'll have 2x minus 5 equals 0. I don't know why I wrote them in weird places, but obviously for x plus 3 equals 0, what do I need to do to solve? Subtract 3. So 4 is to solve. So I subtract 3. So what is our first answer? X equals negative 3. Okay. On 2x minus 5, what am I going to need to do in order to get x by itself? Inverse of subtracting it. I'm going to add 5. So we have 2x equals 5. Is x by itself yet? No, so the party's not over. What do I need to do? Divide by 2. So x equals 5/2. Fractions are our friends as long as they're simplified. Okay, at this point, if you weren't sure, what should you do on step 5? Check your work. Check yourself. Okay. No, unless you did it wrong. Yes. All right, here we go. Our last example of the day. The reason why I gave you this one is because your first intent, your first thing that you may think to do to get this in standard form would be to move your 2x squared, right? However, you want your a to remain positive. So instead of moving your a, you should do what? Move everything else. So you're going to add your 5x and subtract your 12 so that your a remains positive. And that's going to leave you with 2x squared plus 5x minus 12 equals 0. I'm going to stop right here and I'm going to give you the next 3 minutes to follow through with it using example 3 as your guide. Okay. Okay, so once you got to step 2, you realize that a is greater than 1. So could we do a simple factoring here? No, we could not. So we had to do X box or grouping. I don't care which one you did. You just had to do one or the other. X box. So in your X box, you're asking what's a times c? What's
-24.
-24? What is your b? 5. So you're looking for what multiplies to give you -24, but adds to give you 5. And you get 8 and -3. So now you move on to your box. So in your box, you have your first term, your last term, and your magic numbers that work. And then what do? Greatest common factor. So GCF of the rows, what are they? Of the first row, X. Second row,
4.
perfect. GCF of the columns,
Yeah. Oh, 2x.
2x and
-3.
perfect.
Yes.
So your factors are x plus 4 and 2x minus 3. How do we do? Good. Then you set each factor equal to 0. So you have x plus 4 equals 0. And then you have 2x minus 3 equals 0. Step 4 is to solve for x. So how do you solve for x?
-4.
Minus 4. Perfect. X equals -4. Good job. Okay. And then on the other one, how do I solve for x?
+3.
Plus 3. And that leaves us with 2x equals 3.
Divide that by 2, we can get x equals 3.
Good job.
Yeah.
Bam.
Yes.
And if you weren't confident, what should you do?
Check.
Check.
Let's take this out.
All right. How do we do?
Good.
Is it doable?
Yes, it is.
All right.
You